With this, I would like to invite the first speaker, Brendan Gifford, who will help us to recall background information about a chapter with angular momentum. Floor is yours.
Okay. All right. So in the previous quantum class, we talked a lot about angular momentum in a system where you have like a single spin or a single, I guess, nucleus. And so in this case, we wanted to talk about the addition of angular momentum talk about two different spins in the system. And so some examples of this would be the addition of angular momentum and spin in a system where you have, say, an electron that has an angular momentum and spin. You have to consider both, as in case like spin-orbit couplings, and interactions of spins in two systems. So if you have more than one electron and they both have spin, I guess how they interact. And so we know that the spin generally follows these rules as far as which quantum states are allowed, and so those are still the rules for our system. But in this case, in order to modify what we previously learned, we're going to be using some different a different basis, and that basis is, we went over in class, quite detailed, but I guess in simple you can get it from the chart, from what they call Gordon coefficients. And so in this chart, the rows are the magnetic numbers, are M1 and M2, and so then the columns are the combined spins. List the combined spins. So these are the magnetic numbers in these, and the columns here are the combined spins. And then so this is the system it's applicable to. And so then the basis is given in these, I guess, diagonal boxes that you would use for a system of combined spins. And so that was the first major concept, was Gordon coefficients. And so we also talked about term symbols. So these are Russell-Saunders term symbols. And so this was just a way of us simplifying the notation for term symbols. And I actually realized on my slide I forgot to put the term symbol, but it would be 2s plus 1, capital L, and then the base J, which we all remember, where 2s plus 1 is the total spin, L is the angular momentum, and then J is the total angular momentum. And so those term symbols then can be expressed for systems where we have different numbers of spins in the system, so for different elements to get different term symbols. And so then we talked about in great details how to get these term symbols, and then acquired them. What is this?
Which of the applications you like the best?
Oh, which one I like the best? Wait, what?
This is what we presented when we presented.
Oh, I see. Which one I like the best?
Which one do you remember?
Which one do I remember? That's a good question. That's a good question. I would have to say this guy had a pretty good presentation. I think that week, that was the first one. I think Samuel's was probably the best that week. That was my favorite.
But what is it?
Spin states of defects in diamonds for quantum information. He had the Russell-Saunders term symbols in a different notation for I don't know, that might have been Levi.
I had it in a different notation.
Actually, I guess I don't
Because
remember.
that's
Oh,
when
that's right.
it rates the symmetry.
So it was actually Levi's then, where he introduced a different term symbol notation that I didn't quite actually fully get, but for these complexes. Is that it? And then wait. So I want to show a picture that I took. So thank you for being good photographic subjects throughout the semester.
Okay, let's thank Brendan. And